and today we will conduct experiment number 6 entitled Reduction of Sample Size by Quartering Method and Determination of Specific Gravity, Water Absorption, Moisture Content, and Densities like dry relative, saturated, apparent, and bulk specific of coarse aggregates. I am MystJ A. Lomongo.
I am Kathleen, Saloma.
I am Bryanvill Pabate.
Piolo, Sablaon.
And let's start now.
So for the experiment objectives, first one is to determine the specific gravity, water absorption, moisture content, and density of a sample of coarse aggregates into testing sizes by quartering method. And the second one is to be able to discuss the results derived from the data collected in the experiment.
So the materials to be used are first coarse aggregates, sample container, and flat edge shovel. And the lab equipments to be used are dry oven, sieve number 4, and weighing scale.
Place the sample on a solid, spotless, flat surface where there won't be any material loss or unintended foreign material addition. Turn the entire sample over a minimum of 2 times to properly mix the mixture evenly. The last turning shovel the entire sample into a chemical pile by depositing each shovel on top of the preceding one. Use a shovel to press down on the conical pile to flatten it to a uniform thickness and diameter.
Divide the flattened pile into 4 roughly equal portions. Remove 2 diagonally opposed quarters, including all fine material. Continue to quarter and mix the remaining material until the sample is the appropriate size. Two quarters that are diagonally opposed make up the final test sample.
Dry sieve the material through a number 4 sieve and discard any material that passes the sieve.
Wash the aggregates retained on the sieve.
Immerse the aggregate in water at room temperature for a period of 15 hours. Place the entire sample in a container and weigh in water. Remove the sample from the container and drain any excess water from the aggregate. Using an absorbent cloth, roll the aggregate until the surface water has been removed to reduce the sample to an saturated surface dry or the SSD condition. Weigh the excess amount of water.
Let's weigh the SSD of each sample.
For the sample 1. For the second sample. The third sample. Dry the sample in an oven for 24 hours.
After 24 hours, let the sample sit in room temperature for 1 to 3 hours.
So after sitting it for 3 hours, weigh it again to obtain the oven dry weight.
Lastly, calculate the needed data. Showed below are the raw data and results. So the mass of container is 0.08 kilograms and the volume of container is 7.83992 times 10 to the power of -4 cubic meter. And the table shows the aggregate sample physical properties, and the other table shows the aggregate sample mechanical properties. Here are the calculations for the table shown earlier. For the discussions in the specific gravity, the average of the 3 trials for the dry relative of the coarse aggregate sample is 1.8623. That value indicates high porosity and may have a high water absorption capacity. In the saturated surface dry, wherein the aggregate has been submerged in water and has allowed water to seep into its pore spaces, we get the average of 1.9023 and the apparent specific gravity is 1.9391. Apparent specific gravity tells us the volume of the pores of the samples. As we can see in our data, our specific gravity is low, in which often results in poor durability and the low strength of aggregates. For the discussions in moisture content and water absorption, both moisture content and water absorption acquired the same average value of 2.1894%. It was stated that to prevent large variations of water in the concrete mix during production, the value should be less than 2%. However, we acquired an amount of 2.1894%. Therefore, the sample is not ideal to be used since it needs large variations of water in the production. For the discussions in density, according to our data, we got the value of 1,512.40 kilograms per cubic meters for the bulk density, and in our normal density, we got the value of 1,479.61 kilograms per cubic meter. The ratio of the mass or weight of the coarse aggregate particles to the entire volume they occupy is known as the bulk density of an aggregate. Hence, the standard bulk density of aggregate is between 1,200 to 1,750 kg per cubic meter, and our value lies between them. The weight of the aggregate is influenced by the moisture content of the aggregate, which is why it is required to have a constant moisture content. Therefore, we conclude that all the objectives of this experiment have been met. The results of the coarse aggregate sample mechanical properties analysis indicate that the sample has a high porosity. We can assume that our sample is relatively dry and has a normal average density of 1,479.61 kilograms per cubic meters and a bulk average density of 1,750 kilogram per cubic meter that meet the bulk density standard of aggregates. Furthermore, for the moisture content, our average did not meet the standard, but trials 1 and 3 produced data that is less than 2%, which is a perfect sample that will prevent large variations of water in the concrete mix during the production.